Hello, this is Mr. Collier, and today we're doing polynomial long division. Okay, so let's take a look maybe first at some regular long division, like if you want to do something like, let's say, 15 divided by 4. If you do long division, you can do it like this. Actually, let's look at a slightly bigger number, like a 3-digit number. Let's say 133. So 133, then we go like 4 goes into 13 3 times. 3 times 4 is 12. And then we get carry down to 3. We got 13 again. So 4 goes into 13 3 times, and then 3 times 4 is 12. And then we get this remainder, one remainder. We're going to do the same thing with polynomials in a second, right? Recall this means that if you do 33 divided by 4, then that equals, well, our answer is, 133. Our answer is 33, and we get one remainder. That means you get a fraction left over. It's like 33 and a quarter. All right? So we're going to do the same thing with polynomials. You can also divide two polynomials. Let's do that up here. So if you want to divide these, we basically want to figure out what happens when we divide this by this. You can do the same thing. You can go, let's do it over here, x plus 2 into x squared minus 3x plus 5. This is two terms, so I'm going to look into the first two terms here. Basically, what can multiply by x plus 2 to give me an x squared? And that's going to be an x. X times x gives me x squared. I want these to match. X times x gives me x squared, and x times 2 gives you 2x. So just like this here, you're going to subtract. So we're going to subtract these. Be very careful with the subtraction. We're subtracting, that cancels. This is going to give you negative 5x. Bring down the 5, and we get a plus 5. And now you do the same thing. You go x plus 2 into this. We want a negative 5x, so this has to be a negative 5. Negative 5 times x is negative 5x, of course. Negative 5 times 2 is negative 10. Be careful, remember you're subtracting. So this is minus negative 10, and you get 15 remainder. Okay? This means that x squared minus 3x plus 5 divided by x plus 2 equals exactly x minus 5 plus the remainder out of what we just divided by. So these are equivalent. If you take this expression here and get a common denominator and add them together, you will get this one here. So they're equivalent, okay? And the remainder theorem actually tells us that if you want to get the remainder of a linear factor, we can just sub in negative 2, and we will get the remainder. Okay, so we can also do that way. Let's do f of negative 2 means you sub in negative 2 squared, minus 3 times negative 2 plus 5. That gives you 4 plus 6 plus 5 equals 15. So you can also just get the remainder using the remainder theorem.